How do you ensure the scalability and performance in the system architecture beyond just writing efficient code? Instead of trying to make a single machine faster, I design system so we can add more instances easily when load increases. We use stateless services, no session data stored in the memory. Instead, we store sessions in the Redis or shared database. Containerize, like we use the containers for, like Docker, Kubernetes for easy scaling. We use load balancers for AWS ALB or NGINX library to distribute traffic evenly. Whenever API traffic doubled, we did not rewrite anything. We just increased container replicas and load balancers handled the rest. We use indexes, query optimization in the database, and separate read and write workloads using read replicas or CQRS command, which is command query responsibility segregation. We apply caching library layers. Caching layers is there using the Redis or CDN to reduce database load. We use connection pooling or lazy loading to avoid unnecessary queries. We set the maximum connection pooling size while making the connection with the database. Here, the trade off is like cache introduces potential data, statelessness. So, I always define a cache invalidation or TTL strategy. And asynchronous and event driven design for heavy or non critical tasks, we use the background processing instead of synchronous API calls. We use message queues, RabbitMQ, Kafka, SQS for decoupling services, and we implement event-driven communication. For example, when an order is placed, publish an event instead of direct calling the order dependent service basically. What will be benefit? Like it improves the throughput and resilience while avoiding request bottlenecks. We use circuit breakers, rate limiting, bulkheads, which like performance is not just a speed, it also is stability under load. Circuit breaker prevents cascading failures if a downstream service is slow or down. Rate limiting control abusive or unexpected traffic spikes. Bulkhead pattern isolates failure between services or thread pools, so no one failures does not take down everything. Monitoring and observability and auto scaling techniques, like uh, we cannot scale what you cannot measure using metrics like a CloudWatch. Using We use the tools CloudWatch for monitoring the metrics of the application to monitor latency, throughput, or error rates. We implement distributed tracing system using the open telemetry to find the slow point across the services. We set up the auto scaling rules based on CPU, memory, or custom metrics. Basically, we are after the development of the application. Basically, we monitor the performance of the application. So, like we use CloudWatch for metrics to trigger auto scaling when API latency crossed 300 milliseconds for 5 minutes. No manual intervention required. Using the CDN edge optimization. For web application, push content closer to the users. So use CDN, CloudFront, for static assets and API with caching headers. We have to enable the gzip compression also, and HTTP/2 for better transfer speeds. Architecture trades offs like one or two microservices scale better but add operational complexity. Catching improves the speed but risk stale data. A synchronous system increases throughput but complicate debugging and consistency. Overall, basically ensure the scalability performance by designing the horizontal scaling decoupling components using caching asynchronous pattern where appropriate. I focus on the observability matrices, tracing, and auto scaling. So we can identify bottlenecks easily, early, and easily. And I also use patterns like circuit breakers, rate limiting to keep the system stable and under heavy load. It's not just about fast code, it's about resilient architecture that goes predictably.